Section 7. The necessary conditions for innovation. Within a continuous equivalent market, social efficiency varies in step with the market's zero WO cycle. The market sits almost continuously in a state of supply exceeding demand. It is under no pressure to raise its efficiency. Innovation unfolds along its established track, and the group it serves is principally the rich. For incremental innovation to actually unfold, there has to be a sustained environment of large demand pulling on small supply. An environment of this kind naturally brings out a structural contradiction in the supply of energy. Energy that was once uneconomic gradually becomes economic. In the direction of energy, an N+1 innovation appears. To control and use the new energy, innovation in the areas of the market that handle that control will unfold of its own accord. Market capacity expands as a matter of course. The necessary condition for innovation to occur, then, is large demand pulling on small supply. Looking across the history of human development, the only sustained environment in which large demand pulling on small supply truly took hold as the dominant condition of a market came from the age of discovery. We have already mentioned that in an agricultural society, the cost of transport ran at between 10 and 20 times the cost of producing the commodity itself. Without solving the transport problem, no large volume demand could ever form. Without large volume demand, innovation stays locked on itself. The Song dynasty also created an environment of large volume demand. The problem the Song could not get past was that the number of suppliers was even larger. The market pattern the Song produced was therefore large pulling on large. The pattern facing China today is the same. A pattern of this kind cannot put a market onto a track of multiplying efficiency. The age of discovery, by contrast, gave the small population countries of Europe an environment of large pulling on small. The age of discovery supplied innovation with the conditions set out below. First, parts of the world's coastal regions were connected by the cheap cost of water transport, and a wide market system at low transaction cost was set up. Market capacity dung the variety of commodities, chun the frequency of transactions, chun the number of effective consumers. A market grafted onto cheap water transport saw transaction frequency rise sharply, which then pushed the other two variables up alongside it. A multiplier effect was released, and an environment of large volume demand was opened up step by step. Cheap sea transport also allowed grain to move freely across the globe. People from regions across the world gathered onto coastlines. The conditions for coastal cities to rise and to grow were thereby created. This in turn reinforced and expanded the market capacity already in place. Second, a fragmented Europe was dominated by small countries. Once a small population country secured a trade monopoly, a long-running shortage of labor was the necessary outcome. Large demand pulling on small supply must, by its nature, bring with it a continuous need for efficiency-raising innovation. Britain, as an island nation, sits in a position of natural monopoly. Under equal technological conditions, this position greatly raises the difficulty of outside invasion. At the same time, in a market built on cheap sea transport, the water transport advantage of an island nation becomes ever clearer with the passage of time. By way of comparison, a modern enterprise that can sustain a net profit margin of 5% is already exceedingly rare. Drawing on cheap water transport, the all-in cost of British goods could comfortably sit 10+% below that of other regions. Even several hundred years on, this cheap water transport advantage remains. China imports coal from America at a transport cost of only some $20 per ton. The transport cost per ton of coal from Baotou in Inner Mongolia to Qinhuangdao runs at nearly $50. To carry coal from the more distant Xinjiang to inland Henan, the transport cost approaches $80 per ton, while the pithead price of coal in Xinjiang itself is only some $10 or so. The American shale gas revolution hit American coal directly and indirectly hit the whole of China's heavy chemical industry. The stock market has shown this clearly. Coal stocks, construction machinery stocks, and other heavy chemical stocks fell sharply across the board over the past 2 years. They fell from highs in the tens of yuan to lows of just a few yuan, 400 years ago. Drawing on the efficiency advantage of water transport, Britain established a general efficiency advantage as a matter of course. With the passage of time, This efficiency advantage gradually fixed Britain's leading position into place and won for Britain the environment of large pulling on small. In past research, attention has tended to be fixed on particular devices such as the steam engine and the spinning frame, while the continuity of the rise in efficiency and the sustained profit that large volume demand offered to innovation have been left out of sight. In chapters 2 and 3 that follow, we shall, from the angle of the whole market and the whole industry chain, reconstruct the path along which British innovation occurred and the trajectory along which efficiency rose. What we need to notice is this. Large C intro pulling on small edge shares the same essence with savings gives profit, with a commodity is energy controlled by intelligent automation, and with the zero WVO cycle. What the large side supplies is savings. The small side supplying the large side is the same thing as the falling share of human contributed energy contained in a commodity, which is the reason efficiency rises. The uniqueness of mathematics determines this. The direction of innovation is itself unique. In the chapters above, we have, from different angles and in mathematical form, worked the matter out. The conclusion arrived at, in each case, is the same. Once mathematics is taken as the starting point of the logic, the market and innovation can be solved for from any angle without producing contradiction. Every problem of the market is a problem in mathematics. The hand of God is demand. Once demand is met, the market contract of division of labor and cooperation begins to fail. Part of the population is excluded from the market's system of division of labor and cooperation, and the size of that group rises continually. This is the root reason that markets fail and that crises occur. The natural sciences only become true sciences once they are grounded in mathematics. In the same way, the social sciences only become true sciences once they are unified into mathematics. Science is undisputed and measurable. The undisputed and the measurable are the reliable fulcrum on which any problem can be solved.